Welcome to second part of linear regression. This is the summary of previous lecture. We studied one variable case, that is we have one input variable and one output variable. For example, input may be CGPA of student and output may be the average CTC, so that we can find relationship between the average CGPA and average CTC. Now practically we can have multiple parameters as input which will affect the output. For example, if we take the CGPA CTC example, suppose we have dependence of CTC on not only CGPA but performance in individual subjects. Let's say x1 x2 up to xn. Suppose x1 is the grade of math 1 course, x2 is the grade of some programming course, x3 is the grade of Python course, so on and so forth. And let xn be now parameter which denotes the usual CGPA. So now what will be the input output relationship in this case? Here is the relationship. See, we have x1 is the we say it feature is a grade of math course, x2 is the grade of programming course, so on and so forth, and xn is the CGPA and y is the CTC. Now theta 0, theta 1, theta 2. What is theta 1? Basically theta 1 tells you what is the weightage of math course in deciding the average CTC. What is the weightage of, similarly theta 2 means what is the weightage of programming course in deciding the CTC. What is the weightage of theta 3 means weightage of Python course in deciding the CTC, so on and so forth. And theta 0 we call it bias point. This is very important to make the relationship as close as possible. It is basically the y-intercept. So this will be the input output relationship. There is one more name for this whole thing. See, this creates actually one hypothesis. There is a hypothesis like what is the average CTC is a hypothesis based on the input. So it has a special symbol, we call it h theta of x. Okay, so we can also write y is equal to h theta of x. This is basically the hypothesis function also. What do you mean by hypothesis? Suppose someone tells you the weights theta 0, theta 1 up to theta n, and then someone tells you the CGPA of a student and grade of student in different subjects. So what is your hypothesis about his average CTC? That is what its meaning is, one more meaning. So this is the notation for it, short notation. So wherever we need to write theta 0, theta 1, theta 2, theta 0, theta 1, theta x1 plus theta 2 x2, we'll write h theta of x there. Now to make notation consistent, we define one constant x0 as 1. Then we can write this h theta of x, the hypothesis function, as theta 0 x0 plus theta 1 x1 up to theta n xn. Yeah, it will make it consistent and uniform, and you will see the benefit of defining this. See, x0 here is 1, so basically it is theta 0 itself, but this way it becomes uniform and we can write it as a summation, single summation function like this: theta j xj summation over j is equal to 0 to n. Now what is the benefit? Let's try to write it in the vector form. So how will we write? So we define vector x whose components are x0 to xn, and a vector capital theta like this with underscore. Basically these are bold letters, but we can't write here bold letters on board, so I'm writing it underscore, this underline. So now if you see this hypothesis function, h theta of x can be written as theta transpose x. You can check theta transpose x. You know that y transpose x is equal to the components multiplied and then summed up. So this makes it convenient notation of this hypothesis function. And this problem is called multivariate linear regression problem, wherein you have multiple input variables which affect the output. Here we assume there is only one output. There are class of problems where outputs can be multiple, but we will not study that here. Now comes the question how to solve this. We have seen how to solve the one variable problem. So we need a data set for it. Fine. Suppose now you have these x1 to xn. These are called actually not the features. Okay, these are called features, and this vector x will be called the feature vector. Now we will have data set corresponding to each feature. Suppose you have x1, the grade in the math course. So there will be data set. Let's say there are m points, or we have the grade of m students. So this will be x11, x12 up to x1m. Similarly for feature x2, we have x21, x22, x2m. It means suppose x2 is the feature that is grade in programming in C language, and you have grade of m students here. Okay, so this is x21, x22, x23, x2m. Suppose similarly we have xn, that is the CGPA. So here is the feature vector for that. I mean the training input x1n, x2n, and xnm. And the corresponding output will be, suppose for this it will be y1 hat, for this it will be y2 hat, for this it will be y3 hat, what you will estimate using the regression formula, and the real output will be y1, y2, and ym. In this way, okay, let me elaborate it. Suppose we consider the first instance of all training samples, that is, look at here, suppose the theta 0 is there, theta 0 x0, it will be same for all the training samples, plus now theta 1 is the weightage corresponding to the feature vector x1, which is here the grade in programming, and the first component is here 1, fine, plus theta 2 x2 first training sample, plus theta n xn first training sample is equal to, so this will be y1, okay, sorry, y1 hat. Basically this is the estimate, or you can also represent this with h theta of x1. What is this x1? Basically x1 is the vector of all these x01, x11, xn1, okay. So you can write it in both way. Now for another training sample, what will be the hypothesis function? So h theta of x2 will be theta 0 x0 plus theta 1 x12 plus theta 2 x22 plus theta n xn2. It means that student number 2 is there. The grade of student number 2 in mathematics is some x1, in programming it is x2, so on and so forth, and CGPA of student number 2 is here xn2, and we write here y hat of 2 as the estimate of his average CTC, okay. Whereas in data set, if you see data set, we write like this: data set is given as, suppose for student number 1, this is the grade in mathematics, this is the grade in programming, this is the grade in Python programming and other courses, suppose electronic devices, communication system, signal system, you represent with x4, x5, x6, so on. And finally we have xn, this is the CGPA, and y1 is the output. This is the real actual CTC of previous student. So data set contains the data of previous students who have already got the job, offers, okay. Similarly, this is one data set point, the other will be x12, x22, x32, xn2, and y2. What does it mean? It is CGPA of second student number 2. x1 suppose means mathematics course, x2 may be programming in C course, x3 may be Python programming course, so on and so forth, and xn2 is the CGPA of second student, and y2 is the actual CTC that second student has got. Now how many such samples are there? Last point in this data set will be x1m, mth student, x2m, and xnm, ym. And what will be the in between point? So some jth point, it is a jth feature or jth input, and it is so it is an M, but I'm saying in between. Suppose you take any, so this is the first sample point, first training sample of all the students, of student number one of all the subjects and CGPA. This is the sample point number two. So there will be some ayat. What do I ayat? I will write here x I. So in between x I, sorry, xji. Yeah, now it is fine, perfect. What xji means? So it means like this. Let me write here xji. So j is the feature number. Feature number means, suppose it is the jth input, and I means here it is the ith student. Okay, for example, if j is 4 and I is 6, so it will be x 4 6. What does it mean? That we have a student number 6 whose x4 may represent, suppose, his his grade in maybe communication system course. So that is this notation all about, okay, which I have explained here. And now is the question, how to get these weights computed, estimated, or learned, theta 1, theta 2, theta 3, because unless they are known, we cannot use this relationship to estimate the CTC of new students. So for that, we will do the same thing as we have done with the one variable case, but since there are multiple variables, so we need to write it in the proper way. So for ith student, what is the estimated output? See, the estimated output will be h theta of xi, which is actually written as summation j is equal to 0 to n theta j xj of I. Okay, if you have any confusion, you can rewind back and try to understand here. See, here is the estimate of output, that is CTC here, with respect to the inputs, where an input x1 is CGPA of some subject, suppose programming, x2 is CGPA of other course, and xn is a CGPA, sorry, not grades of course, and xn is a CGPA, overall CGPA of the student. Okay, so this is the estimated output, right? So you can write it in theta transpose x also, or y hat of I. Now what is the actual output? That is y of I. Fine. Now what is the mean square error or loss function? So let me write it here. Loss function, cost function, mean square error. Loss function and cost function are most popularly used. Now the actual output, the estimated output is y hat of I, and the actual output is yi. So its square of the error is this. For all the samples, what is the average of this error? I is equal to 1 to m, 1 over m. For the purpose of simplicity, or you can say just to avoid number 2 while differentiating, we add here 2m. And this is what we call as loss function j of theta. Definitely this function of theta. I am writing here the vector theta. So basically you can write in detail j of theta 0, theta 1, theta is function of all thetas, right? And we can also write it as 1 over 2m summation I is equal to 1 to m. We can here write what is the estimate? It is h theta of xi minus yi square. What is another way to write it? 1 by 2m summation I is equal to 1 to m, and we can write here theta transpose xi minus yi square. Even you want to write it in a more horrible way, so you can write as this theta transpose x as j is equal to 0 to n theta j x I j minus yi square. And this is the loss function, and the goal of this machine learning algorithm will be to minimize, to find theta which minimizes this loss function. And you all know what is the first step for minimizing it. Put the gradient of this theta j of theta equal to 0. And you know what is gradient? By definition, it will be del upon del theta 0 of j del upon del theta 1 of j dot 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 del upon del theta n of j. Put that equal to 0 0 0. Okay, so just like in one variable case, you have here n plus 1 variables basically, because theta 0 is one variable for us, theta 1 is another variable up to theta n. So you have to differentiate them all and put that equal to 0. That will provide you in terms of the data set the estimated value of the weights or the parameters theta 0, theta 1, theta 3. Once you know that, then you know the input output relationship. Let me repeat it here what we are doing. See, we are given the data set. Let's write some examples here. Let's suppose this is a scenario. We are considering data of, so 1 to 100 students. You see here I is equal to 1 2 3. So this is basically student number 1, student number 2, student number 100. Okay, and we are not taking care of all subjects. Suppose we are basically trying to get the CTC of a student in company where only these subjects matter: mathematics courses, C, Python, communication system, signal system, probability and stats, DC, data comment, overall CGPA. For the sake of argument, okay, you can take all the subjects. Now let's take student number 1. That student has 8 grade in mathematics, 9 in C, 9 in Python, 7 in communication system, 8 in signal system, so on and so forth. And overall CGPA is 8.8. Okay, let me write it again, 8.8. And that student has already been placed, and average CTC is 18 lakh per annum. Fine, this is our output Y. Now look at the notation. This, if you look at, suppose this 6, number 6, in terms of notation, what it will be? X student number 2. You see, this is S2, I is equal to 2. So that I will appear here 2. And it is which subject? X1, X2, X3, X4, X5. So it is 5. So X5 to like this is equal to 6. Fine. Can someone tell me what will be X 107? Good. So you can right now pause the video and think about it. So X7 is here. Fine. And M is equal to 100. 100 row is here. You can just look at this. So it is this 10. So the grade of student number 100 in course digital communication, and it is 10. So this is equal to 10. Fine. And what are these CTCs? They are basically, suppose here is 18. So 18 is basically Y superscript 1 is 18. Similarly, Y 100 is whatever 22. So this is the data set. Now the first thing which you will see in the Python implementation session in the next video, we divide this data set into 2 parts. Suppose right now we divide into 2 equal parts. Let's say 50 students here and 50 students here. So what we'll do, the data of first 50 students will be used to train the algorithm. Train means this thing. See, and that is actually I should correct myself. This M is not this M with respect to the algorithm. Rather than this M will be 50. So this actually I should write as here 2M is equal to 100. Okay. So we will take the data set of I is equal to 1 to 50 students. So here we take the data of 50 students, and you see when you will put this equal to 0, or if you go to back to previous lecture, you will see there you need to differentiate this J with respect to different thetas, and then the value of xji will be taken from this training data set. That way you will get estimates of thetas. Then testing data set will be used to compute the error. that suppose you have this 100 students. I know that the actual CGP of CTC of 100 students is 22. But what I will do is, from first 50 students, I will learn values of theta 0, theta 1, and theta n. And then I will feed as input this 9, 10. So it will be like this. 9, so theta 0 x 0 plus 9 into theta 1 plus what is the next? 10, 9, 10, 8, 9, 10. 10, 9, 10, 8, 9, 10. So 9 into theta 1 plus 10 into theta 2 plus 9 into theta 3 plus 10 into theta 4 plus 8 into theta 5 plus 9 into theta 6 plus this is theta 7. Okay, this is equal to whatever we get. We will get, suppose given the value of theta 1, theta 0 and all, we get here 19.5 lakhs per annum. So this is our y hat or h of this x 100. Sorry, it is 100. Yeah, 100. Fine, because we are taking this data of student number 100. And what will be the error? So y hat of 100 minus what is the actual salary or CTC? Y 100. Okay, this square. So it will be 22 minus 19.5 square. This way we can get the performance of our linear regression algorithm. How is it working? Fine. So I will end here because I don't want to make longer videos. Now next video will have some more discussions on it, and also I will show how to implement linear regression in Python, and that way we will start using the famous package called sklearn package. Simultaneously, since we will need to access the data set from Excel sheets, so I will show you parallelly some functions from the pandas package, which is used to take data from Excel sheets and save it in Python as data frame. We'll learn about that in the next video. Thank you.